Okay, Trig, this is section 5.7, solving trig equations, both specific solutions and general solutions. Now, I have on this particular graph a basic sine function. I know because it starts out at the origin, okay, and it repeats the pattern 2 pi units later with values at the center line every pi units. In between we're at the max of 1 and at the minimum of -1. Okay, and these values I'll highlight a little bit better here, 1 and -1. Okay, hopefully it's not so bad to see. I'll zoom in a little bit so it's a little bit easier. So here's a sine function. Suppose I wanted to know, okay, I'll come back to here in a minute, when the sine of theta is equal to 0.8. Alright, now let's do two things. The first part is we're going to find specific solutions. From, say, 0 to 2 pi. Okay? And then after that, we will change those to general solutions. Okay? So, now one of the things we can do is we can make this equal to y1 in our calculator and this equal to y2, and I'll show you that in a minute. Now, in doing that, what we're going to see is a graph that looks like this. Well, 0.8 is about right here, okay? So if I were to draw a horizontal line through the graph, for 0.8, I would see that it crosses the wave many times. In fact, if you back out, you can see more of the times where it hits. I wonder if it looks better. I'm going to switch to the regular graph, so maybe I don't know. I'm just trying to see if I can make this a little easier on the eyes. It seems like it's hard. Yeah, maybe that will help if I change maybe the detail a little bit. I don't know, I like that. I'm just trying to get those squares to look a little bit nicer so that they're not so doggone bright. Or the grid. Anyway. Nope, that's not helping. So I can see from the graph that there is a solution right here and another solution right here where the line crosses the wave. There's two of them, right there and right there. So in between 0 and 2 pi, if I'm only going to look there, because that's what they said for the very first question, then there's only going to be two solutions in between 0 and 2 pi. And for some reason I didn't grab my graphing calculator, so let me grab my graphing calculator. Can't even talk. Oh. So I'm going to duplicate what we have right here. I'll zoom in so it's a little easier to see the graph. Under y equals, we'll make sure no plots are turned on. And we're going to use sine x. Now the x is right, you know that's right. I'm going to use the xt theta n button for x. And then I'm going to use 0.8 for x. Now we know that we want our calculator to be in radian mode, so let's just double check our mode. It's in radian mode, okay, that's good. We want the window to go from, say, -2 pi. Pi is above the little caret symbol, all the way to maybe, I don't know, let's see, 4 pi. And we can go in increments of pi over 2 if we wanted to, pi over 2, at least for the x scale. And for the y scale, obviously we want to go, I'm going to say -1.5 to 1.5. That'll give us just a little bit of room to kind of view what's going on here. And so we should get a shape that looks something like this. And the line will come through and it will hit it. a few different times. Now, if you just want to look from 0 to 2 pi, you know, because you really want to focus in on the specific solutions inside of this range, then maybe you would change the window to something like this. We could see from the graph that it is going to have two solutions, one there and one there. Now, I can't really draw too much on the graph here, but this is negative pi over 2, or positive pi over 2. Now, I know positive pi over 2. I wonder if I mark on the screen if it can be erased. Okay, let's do that. How about this? This would be pi over 2. Ooh, that really turned out blurry. Pi over 2, if you divide it out, is actually 1.57. I'll erase those here in a minute. And maybe this will help you, though. So when you do calculate, oops, that's really going to be nasty. We want to calculate an intersection point, don't we? Is the first graph y equals sine x? Sure. Is the second graph y equals 0.8? Sure. So I'll hit the enter button again. Do I want to guess? Now here's where the guess feature might come in handy. If I could guess, if I knew that's 1.57 and I want to find this one, I'm going to go lower than 1.57. So I'm going to actually guess a 1. Now what that's going to do is it's going to force the calculator to go to the lower part and find the lower value. It ends up being 0.927. 0.927. And I'm going to write that down just so I have it, 0.927. Okay? Now I need to find the other one, right? So I'm going to calculate intersection. Now you can either use the cursor and go closer to the other one, or you could type a number larger than 1, right? So if you get it close to this other one, oops, I'm not to the guess part yet. Why am I even thinking about that? So the first curve was y, was the sine function. Second curve, is that equal to y equals 0.8? Yes. Guess, now that I'm close enough, it doesn't really matter, so I can just hit the enter button. It will go, because my guess was closest to the other value, it went and found the other one at 2.214. Now, what's the distance from here to 0.927? Of course the answer is 0.927. The distance is 0.927 from 0 to 0.927. What's the distance between pi and that answer? Also 0.927. So we could have easily, just to double check this, we could have easily found the other solution by saying trace. Alright, let's say we were way down here somewhere. When you hit the trace button, you're allowed to type on the calculator. And if I had said pi minus 0.927, it would go from here backwards 0.927, and I bet you it lands pretty doggone close to 0.8. And it does. Now, obviously, it's not perfect because I rounded the 0.927. But you'll notice that it's 2.214, or I obviously would round up a little bit, but you get the idea. So I can use that distance to find this other value as well. Now, so my two specific solutions for part A, 0.927, comma, 2.214. Now remember, those are in radians, so those aren't degree measures. This is approximately 6.28, right? So it makes sense that my answers have to be smaller than 6.28. Now what's the distance from this solution up to this solution? Hopefully you all know that that's the period of the function, which is 2 pi in this case, because we're dealing with a just plain old sine function. So we can change that to a generic equation by taking the point 927 and we add 2 pi. Well, that's not really generic. That actually only gets us one more solution. But what if we wanted to do it again, add another 2 pi and another 2 pi, or subtract the 2 pi and subtract the 2 pi? Then we can use the letter n. Notice how I put that 2 pi n, and I'm going to say where n is an element of the integers. Okay, so that's what that funky notation means. Where n is an element of the integers. Because if n was an integer, right, then you could be adding or subtracting 2 pi, but you could do it forever and ever and ever. Now I want you to notice something though. I want you to notice that when I added 2 pi, notice that I skipped the other solution right here. Each time you add, you need to look and say, did I skip over one of the possible solutions? In other words, since I had 2 specific solutions inside of one cycle, I will have 2 general solutions. So what's the distance from here all the way to here? Once again, also 2 pi. So I'm going to change that to a general solution by writing it down. 2.214 plus 2 pi n, where n is an element of the integers. Really, you only need to write this where n is an element of the integers one time. I just did it for fun. Okay? But you'll notice that I added the period times n. Period times n. So you're probably thinking to yourself, well, do you think he'll ever change the period of the function? Yes, but let's not get to that one quite yet. Okay, so now I've got a cosine wave. I know this because 0 is 0, 0, hk is underneath the maximum. Okay, we got a negative 1 down here. We got a positive 1 up here. It repeats the cycle after 2 pi. Okay, so it's a plain old cosine function. What if we had cosine theta equals 0.8? Could we do the same type of thing? Well, sure, 0.8. That goes right through here. And if I'm only looking for specific solutions from 0 to 2 pi, one of them is going to be here, and the other one's going to be here. Whatever this distance is from here to here, it's going to be the same distance from here back. Now, so I'm changing my equation to look like this. Y equals cosine x, and we got y equals 0.8. I can keep the window from 0 to 2 pi. That's not going to change. So when I graph it, I'll get a shape that looks like this. That's one complete cycle of the cosine wave, and the line cuts through. And I could do the calculate the intersection of the two. First curve is the cosine. Second curve is y equals 0.8. That's 1.57 right there. That's pi over 2. So I'm going to go 1 for my guess, and that'll throw me over to the left side to the 1 on the far left. 0.644. Okay, so 0.644 is the approximate solution for that one right there. So that's one of my specific solutions. Now, suppose, I guess I bet I could write a question so that you can't use, if I gave you one of the solutions, you would have to write the other solution as 2 pi minus 0.644. Now we can use a calculator to find that. It's not that difficult. In fact, I'll do that on the graph so you can see that if I use the trace button and I type 2 pi minus 0.644, it will land right there, and the y value will be doggone close to 0.8. The value is 5.64 approximately. These are the two specific solutions, 5.64. It has to be less than 6.28, right? Because that's 2 pi. So here are the two solutions, the two specific solutions. Now if we want to change them to general solutions, not really all that difficult, right? We got 0.644 plus the period of the function times n. 5.64 plus the period of the function times n. And like I was saying earlier, I would only write this once, where n is an element of the integers. Yes, you do need to write it. Don't try to cheat me out of my where n is an element of the integers. Plus, it's really cool to write that letter, that, you know, really weird looking E and the double barred Z, you know. Okay? Now, can we do things with negative values? Sure, we can do things with negative values. Okay, so sine theta equals negative 0.25. So, you know, hard part about it is that's kind of right in the middle here. One of the solutions obviously is just a little bit larger than pi. Okay, according to the picture I've got here, one of the solutions is just a little bit bigger than pi. Okay, you know what? It would be interesting if you did the inverse sine of negative 0.25, if you knew where that answer is, negative 0.253. I hope you all realize that's right here. Now, how could I use that to tell me what this one is? Well, this one has to be pi plus 0.253, because that's a distance right there from 0 to negative 0.253. That's only 0.253 units. So this one, a little bit larger than pi, has to be pi plus 0.253. Okay, on my calculator that gives me 5.672. Okay, which is approximately 5.672. That is a specific solution from 0. And how could I also find the other one right here? Well, remember, you're coming backwards from 2 pi. So I'm guessing 2 pi minus 0.253. So the other solution would be 6.03. And then, of course, since we're dealing with a sine function that has a period of 2 pi, nothing has been changed in the horizontal direction. So that means that your general solutions would be plus 2 pi n. Cosine. Let's say cosine theta was negative 0.25. We could draw a cosine wave, and here's approximately where negative 0.25 sits as it goes through the graph. Just approximately. Looks like we have a solution right here and another solution right here. So, if I invert the cosine of negative 0.25, it gives me 1.823. 1.823. Well, we know that the inverse cosine has a range between 0 and pi, so it has to be that one right there. 1.823. So that's the distance from here all the way to the solution. So guess what? The distance is from 2 pi back to that solution, 1.823. So this one right here is 2 pi minus 1.823. 2 pi minus 1.823, which gives me 4.46. 4.46. So there's a solution, there's a solution. It's not really that hard to find the specific solutions. And then, of course, because we're talking general solutions and the period hasn't changed, the period is still 2 pi, because nothing has been altered, then, of course, to change them to general solutions, it would be plus 2 pi n. Now, the tangent functions, the good old tangent function. Suppose you were given the tangent of theta equals, let's say 1.7. You know, let's just make it nicer on ourselves. 2. So 2 runs right through here. Let's suppose I wanted specific solutions. Specific solutions from negative pi over 2 to pi over 2. Now those specific solutions, obviously what I'm asking you to do is I'm asking you to limit your search to right here. And you can clearly see that there's one answer. So right about in here is going to be the value. Now pi over 2, that's 1.57, so it's somewhere between 0 and 1.57. Now, curious, can we invert the tangent of 2 and get an answer that's between 0 and 1.57? Sure. And when we do, we get 1.107. Guess what? That's it, 1.107. There's only one answer between negative pi over 2 and positive pi over 2. B, how do I change that to a general solution? Well, it's 1.107 plus, be careful, what is the period of the regular tangent wave? Only 1 pi. So this would be pi n, where n is an element of the integers, or for some of you, integers. Okay, if you're trying to remember phonetically. So every time you add another pi, that's going to jump you from this solution up to the next one, or to the next one, or backwards to that one. Okay? Because you're using the period of the function to go and find the rest of the solutions. There are not 2 specific solutions inside of this window, so you won't have 2 general solutions. So you only have the same number of general solutions as you do specific solutions. We're going to start doing other types of problems where we're taking functions and maybe we're solving them. Okay, that number really has nothing to do with anything, but so I may ask you to actually solve an equation. Instead of telling you that it's sine theta equals negative 1/2, I might ask you to actually do a little bit of algebra to get it to this point, and then you can go through the process of finding specific solutions and general solutions. The more challenging questions to you are when we're going to start changing the period of the function. Remember, this is the same thing as theta over 1/2. So the period of the function we know is 2 pi times a. In this case, 2 pi times 1/2. Therefore, the period of this sine wave has been changed to only 1 pi. Now, there are a couple solutions for this one, but this is probably one I don't even need a calculator for, right? Because how do you get rid of sine? You do the sine inverse. So 2 theta is equal to sine inverse of radical 2 over 2. Well, think about that. Where is the y value equal to radical 2 over 2? Between 0 and 2 pi. That's one trip around the circle. Well, that'd actually be equal to pi over 4 and 3 pi over 4. Now those are both equal to 2 theta. If you solve for theta, you have to divide by 2 on both sides. Theta, oh sorry, I'll write it over here. Theta would then be equal to pi divided by 8, or 3 pi divided by 8. In other words, if you have reduced the period of the function to pi, you did a vertical or horizontal shrink. Now we're talking about a sine wave, right? That goes from 0 to pi. Radical 2 over 2 is still somewhere in here, and it is still going to cross it twice. And one of those solutions is going to be pi over 8, and the other one right there is going to be 3 pi over 8. Quite honestly, I didn't need a calculator for either one of them, because I know my unit circle, and I know that radical 2 over 2 has a y value both at pi over 4 and 3 pi over 4. And all I needed to do was divide those by 2 to find out that it was pi over 8 and 3 pi over 8. Now, can I do that with a graphing calculator? Can I get in here and say cosine, sine 2x and radical 2 in parentheses divided by 2? Can I get in there and do that? Can I make my window? Or should I just use the old window? Well, keep in mind we did a shrink, right? We shrunk the thing by 1/2, so it should only have a period of 0 to pi. So we reduced our graph down to this. If I do trace and I do pi divided by 8, let's see if I land on one of the solutions. Oh yeah, radical 2 over 2. Now for those of you who don't know, in TD land, radical 2 over 2 is 0.707 approximately. I know, fun fact for parties. And 3 pi over 8, 3 times pi divided by 8. Also another radical 2 over 2. Fantastic. Those specific solutions were between 0 and 1 pi. Well, that makes a whole lot of sense because we reduced the whole thing by 1/2. Now, how do I change those to general solutions? Well, we take the pi over 3, or pi over 8, and we add pi n. We take the 3 pi over 8, and we add pi n, where n is an element of the integers. I know that one is going to have to make sink in, and we're going to have to practice some more of those. How about this one? Sorry, I'll rewrite it so it looks halfway decent. Cosine theta over 3 equals negative 1/2. Okay. It looks like we did a stretch, right? A is equal to 3, so that means the period of the function has gone from 2 pi to now 6 pi, right? Because you stretched it by a factor of 3. Now, if you invert the cosine, right, theta over 3, and you try to think in terms of values on the unit circle that have an x value at negative 1/2, you're going to cross 2 spots on the circle. from 0 to 2 pi. And those two locations would be 2 pi over 3 or 4 pi over 3. Now, what do you do to get rid of? What do you do to get rid of the 3 here? So you just have theta by itself. You would multiply everything by 3, right? Multiply everything by 3. So theta would be equal to 2 pi and also 4 pi. Those are the two specific solutions. Now, what's the period of the function? 6 pi. So the specific solutions in this case have to be between 0 and 6 pi. Not 0 and 2 pi. And if you try to do that on a calculator and you come back here and you type cosine x over 3 and we have a negative 1/2, we try to graph it, you're probably going, man, that's really weird. Well, remember, we had this set up for a completely different period. The last time we had a period of 2 pi. You want a period of 6 pi. So 6 pi is what you need to be changing the window to. And when you graph it, then you're going to say, oh yeah, that looks like a basic cosine wave, and here it comes. Here comes the line at negative 1/2. And it's going to cross two places. And I need to be able to find both of those. And according to our calculations just a few seconds ago, 2 pi would be one of those. So if I hit trace and type 2 pi, let's see if I go to that solution right there. Sure enough, it's got a y value at negative 1/2, and that is the correct solution. Well, let's see about 4 pi. 4 pi is supposedly the other one. Sure enough, it is. Now, how do I change those two general solutions? So the general solutions here would be 2 pi plus 6 pi n. 4 pi plus 6 pi n, where, sorry about W, n is an element of the integers, or the integers. And that's enough abuse for one evening.